Welcome to the second video in this lesson. We're going to do lesson 2.6, but we're going to do it all in one video, just like we did all of 2.5 in one video. So this one deals with nonlinear inequality. So we're still going to be playing with domain a little bit, but we're going to be looking to see where the function exists with inequalities, mainly where is it greater than 0, where is it less than 0, where is it greater than or equal to. So let's look at this example. I've taken the notes that you had and I kind of cut them up a little bit. So first, the nonlinear inequalities, we have to identify the intervals where that inequality is satisfied. For example, if I only want to know where the function is positive, so that's the function, the y value. If you look at my graph, I've also colored it in purple. It's everything above the y-axis, everything where y is positive, and it's just greater than. So it comes from negative infinity down to negative 4, and these are parentheses everywhere, negative 2 to positive 2, because it doesn't equal 0. But down here, if I go greater than or equal to 0, then I can have a bracket at negative 4, brackets, and I can include the 2 in the negative 2, and I need to include the 5, the 0, the 5 over here. Now this is if it's greater than 0. Look to see what happens when it's less than 0. So if I'm only looking to see where the function is less than 0, that's below the y-axis. And therefore, I would go from negative 4 over here to negative 2. Again, they're parentheses because it's not equal to 0. From 2 to 5, and then it doesn't include 5 because that's at the 0. And then from 5 to infinity. But if it's less than or equal to 0, then you can include, and you have the brackets for negative 4 and negative 2. And look at what happens here. If you can include the 0, then you can just say from negative 2 to infinity. And you don't have to break it up. You need to change that to a bracket. The only other one that we have left out is where it is actually equal to 0. And that is just at those 4 points right there. So when x is negative 4, negative 2, 2, and 5 is when it is equal to 0. Now that is your goal, is to be able to understand graphically when I give you a graph, you be able to tell me where those inequalities exist, but also if I wanted you to do it algebraically, we need to talk about that. You need to identify the critical points. Now the critical points are going to be right here. Those would be my zeros. But I don't know that yet. Pretend I haven't graphed this. So I need to algebraically maneuver that around. So the first thing I'm going to do is bring everything to one side so that I have 0 on the right. Now, you can take everything to the left, but I usually take it so that my square term is positive, because that will make my life easier, and I'm all about that. So I'm going to bring these over. So I have 2x squared. I would have a negative 10x. I'm going to have a negative 2x, and I'm going to have a positive 16 is all less than or equal to 0. Now let's notice a couple things. Right here, I have x's I can combine, and I can factor out a 2 out of the whole darn thing. So I'm going to do that in a combined step. All right, I'm going to take this whole thing, and I'm going to divide by 2, and I'm going to combine this, because that would be negative 12x, so I would have 6x here. So I have 2x squared divided by 2 gives me x squared minus the 6x. 16 divided by 2 is usually 8, and 0 divided by 2 is 0. Now let's talk about this for a minute. It says less than or equal to 0. That means I'm looking for negative area of the graph, which is also below the x-axis, right? I'm looking for the negative areas. So I can now factor this. I know factors of 8 that I can add and subtract to get 6. Let's see, they'd both be negative. because I need 4 plus 2, which gives me 6. I'm still less than or equal to 0. So x equals 4 and 2. Those are my critical numbers. Those are the critical points. That's what I just determined. So when I find those, I'm going to put a number line, and I'm going to put 2, and I'm going to put 4. And does it equal that? Is this less than or equal to? And it is. So I usually put a circle there so that I remind myself that it includes it. It's not an open circle, right? And now I'm going to plug in a number. If a number less than 2 is 0. So if I plugged in 0, then does that work here in the equation? Well, if I plug in 0, I'm going to get a positive value. I'm looking for negative values. Between 2 and 4 is 3. If I plug in 3 here, 3 minus 4, that gives me negative 1. This would be positive. That gives me a negative. Beyond 4, if I plugged in 5. 5 minus 4 is 1. 5 minus 2 is 3. That's a positive. That is not going to be less than or equal to 0. So my area of interest right now is just from 2 to 4, that interval. And I use the brackets because it includes that because it's or equal to 0. Let me just very quickly show you what I would do here. If I were to graph this right here, graph this equation, and then look at it on the graph, you see how you can tell where it is negative, where it is less than 0. Okay? So you can also do that, but there are times when I'm going to want to see it algebraically. Very quickly, if we go back up here and look at the critical numbers here, all of these are critical numbers. So I have negative 4, I have negative 2, that would be 0, that would be 2, this would be 4, and that would be 5. Okay, so if I'm looking to see the positive and the negative here on this number line, and we're going to have you do this on some exercises. All right, so beyond or earlier before 4, that was positive. Between negative 4 and negative 2, it's negative. Between negative 2 and positive 2, it's positive. Between 2 and 5, it is negative. And then beyond 5, it was negative. Now, I'm not going to put circles or dots here because it depends on the problem and on the exercise, whether you're including it and it's equal to or not. All right, now what I'd like to do is I'd like to talk about some special cases.